Okay, so let's start with our next session. Our speaker is Martín Romero Martinez. He is a researcher at the National Institute of Public Health, where he works in teaching and designing surveys on health issues. He has a bachelor and master's degree at UNAM and doctorate at the University of Chicago. And well, he's going to talk about practical experiences in adaptive response surveys.
Thanks for inviting me. I'm going to present my experience on surveys, and some of them are kind of adaptive. This is the definition of adaptive and response surveys. I took from the book of Southern, and I only want to say that the example that I'm going to present is a sort of response survey, because the survey is composed of several stages, and each stage has a different protocol that depends on the previous outcomes. In this talk, I will talk about two topics. The first topic is my experience on the mixed survey. It's a survey that is supported by UNICEF. And the second is an example on inference with unknown probabilities. The first is a joint work with all my colleagues of the INSP, especially with Aurora Franco, she was in charge of the field work. And in the second part is a joint work with Olivia Perez and Ulises Beltran. I talk about these ideas on this problem, and they implemented. Let me start. The mixed survey is a survey that has as a target population the children that have age 0 to 4, and the women that with age 15 to 49. Here in this survey, the main restriction was that the client required at least 6,000 complete interviews the children. But according to the data, there are 0.35 children per household. Then the minimum sample size was about 17,000, which was out of the budget. Then when we were planning this survey, the main conclusion was that with the budget that we have, we cannot do a regular survey. Then we decided to do a sort of adaptive survey that is explained in this figure. First, the first stage is the selection of sampling units, like a regular survey. Next, we did a selection of secondary units that they are blocks or localities depending on the kind of PCU. And then in the blocks, we select an interval of households. And here started the new things for us in that time. The team of fieldwork went to these households, and they asked for children and women. They applied a very, very short questionnaire that was only 3 questions, and was a visit that was very, very fast. The most fast as they can. Then, the next stage, we received the response of the first team and apply a different fraction of sampling for each one of these groups. And finally, the second team of fieldwork went to the houses, and they applied a real questionnaire, and they interviewed all the women and all the children. Here, the let's say, the point that was worrying for us was this. One was this, that the selection of households in the block was very fast, because as we wanted to save money, the people who do this job they did in a very straightforward way. Then then this is the summary of the survey. We did these steps for each state of Mexico. For Aguascalientes to Zacatecas, the first team went to apply the very short questionnaire. It took only one visit. And the second stage, we select the households where a true questionnaire should be applied, and the sampling fraction was different for each state and for each kind of household. And finally, the second team visited the household, and they applied a real questionnaire. They did, as should be, at least 5 visits to try to get a response. And each household was visited by a nurse and an interviewer. And the questionnaire lasted at least 30 minutes. The main point was that the cost of the third stage was about 30 times the cost of the first stage. So this design was, for us, was a sort of adaptive, because we were doing this state by state, and at each stage we counted how many children had, and in order to get at the end of the survey at least the 6,000 children. The goal of the 6,000 children was very important for us, because it was on the commercial contract. So there was no chance to fail in that aspect. And these are the results of the survey in our first visit. The first plot compares the distribution of the households with children, the households that no children but have women, the households with no children and no women. And this compares the distribution in our first visit. With the comparison is made with the results of a health survey that was made also by NSP. And for us, this result was very nice, because the histograms look similar. And once we got these results, the next stage was about to define a different sampling fraction for each of these groups. And that is presented in this second histogram. Here we have the 3 groups, and we have additionally the group where we didn't get information. And this group represents the households with the people didn't respond. We didn't found people about to talk or any cause of no response. So we could say that at fifth stage, we got a response rate of 60%, and this is the distribution. The distribution in red is the distribution of the sample. This means that in the sample, for the second visit to the household, we had about 65% of households for which we had information that they had a children. Then the change, this was the main point of the first stage, to have confidence that we will achieve the 6,000 children. Now I'm going to present what was the variability of the result for each stage. The purple part of this graph represents the fraction of the sample for which we didn't get information. And that is the non-response rate on the first stage. And you could see that it could be at some stage was fine, like this is Chiapas, and for other was high, this is the Mexico City. And in green, we have the percentage of households that had children. So this is the distribution on the first stage. The second plot presents what was the distribution on the sample of the household that were visited in the third stage. In this case, you could see that about 60% of the household were households with children, and now the fraction of households with no information is pretty low, is about 5%. This distribution was helpful to the field work because once they have some sort of evidence that a household had a child, then they put more effort to get a response. And here I could say that probably this could be the allocation of the sample to this strata. We solved in a very straightforward way, and was just to try to get the most of the household that have a children. And the results of the survey was that in 85% of the first stage household with children turned to really have a children. So we could say that in the household that we thought that have a children, we had an error of 15%. But we have also an error on the other household. And 10% of the first stage household without children turned to have a children. The response rate in the second stage was high, 90%, and we are sure that the response rate is because these households are special households. Then, in order to get some confidence on the quality of the data, we made a comparison of the pyramid. Here and on the right, on the left, we have the distribution of age and sex in the mixed survey, and here in the right, I have the distribution of the also age and sex in the health survey made by NSP. This pyramid corresponds only to the households without children and without women. These are unweighted estimated, and for us, that data gave us confidence on the results of the survey. Similar results, we saw similar results for the other strata. I will not present in order to done over. Now, once we finish, we got this. There are practical issues on this survey, and also where we found design issues. The practical issues, we have basically two. The first was that different stages were done by different teams. And by different teams means absolutely independent teams. We did this decision in order to reduce the chances of bias, because in the field work, there is a chance that always let's say, the interviewer can introduce bias to the sample. The next is that it was needed a good coordination among teams, the team administrative, the team computational, the field work. And this was really, really hard to have in practice, because when many people work over one project, it occurs always sort of accidents. And regarding the design issues, the first thing is that there is a cost analysis. That means how much money we save, but also what was the consequence of our saving money into the variability of the weights, and so on the variance of the estimators. The second issue is about the potential bias, because this survey had a response rate about the 54%, which is lower than the response rate that we had gotten in a regular sample. And finally, we had to have some consideration about how to estimate the probabilities of selection. And finally, I had this, have confidence on the law of the large numbers. And I put this because when we did the planning on this survey, we had many questions about the cost of the survey. So we had to rely on really an average cost, and we were glad that we got in the target. But really, it's a hard problem to get a detail, to get all the details on the cost. So we were just on average. I'm going to present the results of the cost analysis that I did for this seminar, not for the survey, because for the survey we didn't have time to do this. We didn't have to take this. But these numbers reflect they summarize the important things. Let's assume that 6,000 children are required, and there are about 1.5 child per household that have a children, and let's assume that the first stage household costs 1 peso and the third stage household costs 30 pesos. This is the results of the survey on households that have children. The frequency is about 18%. Household with no children, the frequency is about 82%. In the households with children, we applied a sampling fraction of 1, and in households with no children, we applied a fraction of F. And at this household, they have children in 85%, and this in the household that we were reported that had no children, we got 10%. We got 10% of households with children. Here, the only parameter to analyze is F, that is the fraction of sampling on these households. The first is about the cost, the total cost of the survey. Here in this, I have the sampling fraction, and here the total cost of the survey. This is just a straight line, except the last point, when we have a sampling fraction of 1, and here the cost is smaller than this because this means that I only need to do one visit. The second graph on this cost analysis displays the effect of design that is approximated as the coefficient of the square of the coefficient of variation of the weights. The weight is 1 for the strata with sampling fraction 1, and the weight is f to the minus 1 for the other strata. And here we see that if the sampling fraction is small, the design effect is larger. And finally, this graph presents the cost of one effective interview. This is the ratio between the total survey cost divided by the effective sampling size. That is the 6,000 children divided by the design effect. And here it shows that is a quadratic form. And here this is the solution for a regular survey. Then here the conclusion is that statistically the best choice is to do a regular survey. The problem is that in order to do this survey, we need a large budget. And if we don't have all the budget to do this survey, that is the best option from the statistical point, we have to find the sampling fraction that is most cost effective. And this means that the best choice is to have a sampling fraction that is the closest to 0.6 in the budget. And here, we were here. Basically, we were here. So we had no choice. We had no choice, but it's glad to know that some solution, some nice graph could explain that. Now, respect to the bias, usually the response rate decreases with the number of visits made to a household. Here, as I said, the mixed survey had a total response rate of 54, 60% for the first visit, 90% for the second visit. So, and a regular survey, I am sure that we could have had a response rate of 80%. So the size of the bias could have increased. And for me, that's no question that lower response rates opens the door to bias. And here is just one evidence from this survey. This survey here in this axis, I have the years of schooling of PCU, and here the response rate that we got in a sampling unit, and this is clearly a trend. So at the PCU with greater years school, now our response rate was lower. So, for me, there was no question that although we saved money, we got into area of risk. And the point that, let's say, I would say for me, because I'm saying I am speaking as a free citizen, is that in the topics of health, the age and sex are the main driving force of the phenomena. And in order to support my statement, I am presenting the prevalence of morbidity in the last 2 weeks. And here I have the age and I have the prevalence. In blue, I have the people with education until elementary school, and in green, the people with education greater than elementary school. And here, the plot shows that the trends are quite similar, up till 65 or like that. So then, from my analysis of this survey, was that although we had a lower response rate than the 80% that it's kind of standard in the regular surveys that we do, for me, the fact that we were able to reproduce the pyramid of age gave me confidence in the sense that our estimator wouldn't have a bias caused by the two main driving force of the health the health status on a population. The second point that was kind of concern for us was about the weights calculation. Why? Because when one study the book, read the definition of probability sampling that says, you should know the probability of selection. And I knew what was the probability of selection of the sampling units, of the second stage, the household, and the fraction of oversampling. The probability selection that let's say, I didn't know with certainty was this. What is it? The household listing? Because the field work did this in a very fast way. So for me, I was clear that here we could have mistakes. We could have mistakes, and this mistake could cause some problem on the estimation of the probability of selection of this at this stage. And additionally, the household response is another probability that is known that we didn't know. But the thing that we estimated as a statistician, we have to estimate. Here, and this plot also, for me, gave me confidence on the estimation of the probability of selection in the blocks. In this, I have the census counting. That is the census counting reported in the data for the census. And here I have the counting for the survey. And there are a straight a trend. It's almost a line. And obviously the slope is not 1. That means that just the people is not counting all the households. And then I'm going to the second part of the talk, that is to discuss about the inference with unknown probabilities. I decided to talk about this because this is an issue that occurs in many surveys, and especially in these surveys that are adaptive, because and I'm going to present an example that works. The PREP is a computer system where the electoral result of the section or precincts are stored and displayed by the electoral authority, and the PREP works on real time. That means that once the electoral authority receives the result of a section, it publishes on the web. The number of sections has varied between 60,000 and 70,000. And here it was a special situation because in this case there is no sample design for the PREP. And there's no sample design, and that means that we don't know the probabilities. And this issue, known probabilities, is a frequent issue in applied survey. Here, in order to get an idea about the problem, I am presenting the logarithm of the total votes according to the registration order. This point represents the logarithm of the total votes of the first section that is recorded by the local authority. And as the time goes, these results get into the system. Here, this is not a line. There is a small curve. And here I present the preference for the two candidates that were the closest to be the winners, the Partido Acción Nacional, PAN, and the Coalición por el Bien de Todos, PBT. The average vote for these are pretty close. And then the steps that we followed to try to solve this problem was first to estimate the probabilities, and next do a calibration. This is the classical sampling setup. I just include in order to have a complete presentation. That is the parameter is the sum of the y's. The estimator is the y's divided by the probability of inclusion. And here, the question that is most important is this expression for the bias. That means that the bias could be zero if the y's have covariance zero, if they are not correlated with this ratio between the probabilities. And our estimators of the probabilities are, let's say, sensible estimators in the sense of the errors of prediction of the probabilities have a suspected value equal to 1. And here, just to comment, this result is important because it says that basically that if you use a sensible model to estimate the probabilities, you will not have bias. And working a bit more, this is the bias, is just the covariance between the y's and the errors of prediction in the probabilities. And furthermore, the square of the bias is smaller than the variance of the y's times the variance of the errors. And so the conclusion is that the bias will be lower to the extent that the estimation error of the probabilities will decrease. This interpretation is very helpful because translate the problem of the estimation, translate the problem of the bias in a sort of regression. And the next stage is, the question is how to verify that the bias is close to zero. Because in the application, in the application, we have only the estimators of the probability. The y's, we don't know the y's because we are going to observe the y's. The real probabilities also, we don't know the real probabilities. So we cannot verify in this setup if we are going to have a bias of zero. And the way to solve this problem is verify that you get unbiased estimators for a variable C such that you know the total of C, and Z has a linear relation with Y. In this case, in this example, we were lucky to think on Y as the votes, the preference of a party in the election of 2006. And we work with Z as the votes of the preference for a party in 2000. Then, under the assumption that the votes of a party in 2006 will have a linear relation with the votes on 2000, on this assumption, and verifying that our estimations of probabilities gave us unbiased estimators on Z, we can have confidence that our estimator on Y could be okay. The second tool to solve this problem was the calibration of weights. And here I am just presenting the ratio estimator. This is the parameter, the total of X. We know the total of C. Next, we consider the ratio estimator, where these are our estimator for the total of Y and the total of X. And I say that this is a calibrator estimator in the sense that when Y is equal to X, the total of X is estimated with the total of X. In that sense, it's a calibration weight. Then, in this case, the bias could be expressed like this covariance, and this covariance can be bounded by the product of the variance. Then the final conclusion is that the variance decreases if the prediction of the models improves. Which models? The model that predicts that probabilities and the model that predicts the Y's. And this is the regular result that is presented in the books of sampling, that the ratio estimator is as good as this relation holds. And here I did just a simulation just to verify that the simulation coincides with the math. And only to comment that this is the sample standard deviation for the ratio estimator, and this is compared with the sample standard deviation of the regular estimator. This is quite larger. Then I'm sorry, in this I forgot to say that in this simulation I worked with this population 1 to 50 twice, and I select a sample of 20 units with replacement and probability proportional to X. But I assume I did the estimation of Y, this, with a ground model. The ground model is that I use the probabilities of the simple random sampling. Although the units were selected with probability proportional to the size, but the ratio estimator fixed the things. The reason by that makes to the ratio estimator to fix the things is this component, because these variance, because this equation. Because the error of prediction on the probabilities is not correlated with the error of prediction in the model of Y and X, and that makes that this estimator is basically unbiased. This is the estimator, and this is the parameter. And then after applying those results to our data, we estimated the probabilities of selection as the percentage of section with response for each stratum defined by the cross product of rural, urban localities and circumscription, 5 circumscription. These are set of stage. And also, as a calibration, the total votes were calibrated to be equal by circumscription. This calibration was similar to the calibration, let's say, to the real world, because in the data analysis that we had, the percentage of total votes by circumscription were these numbers, and I calibrated with 20%, 20%, 20%, 20%. I did this because in practice we don't know in practice we don't know this distribution when the estimation is done. And finally, this is the, let's say, a nice plot. A nice plot because coincides with the math. And here, this is present the bias, and here the sample size, and I am comparing the bias on the difference between the two parties. And here is this line is the estimator that is just the sample average of the total votes. So using the sample without correction, without model, it has some bias, and then the bias vanish. But if we use an estimator that adjusts by response rate, is this line. The bias is smaller. But if we use the estimator that use the non-response and this calibrated, the bias almost disappears. And here I share two things that occur in practice. Big data is not equal to good data, and data, more sensible models, that we could get useful results. Finally, I am presenting the estimates of the preference, the votes for the two parties. And these lines, dotted lines, show that the estimators that use just the sample average, the difference is quite large at the beginning. Quite large at the beginning, but obviously at the end they are pretty close. But this line, this line shows that if we use the adjustment by non-response and the calibration, the estimator is pretty close since the beginning. Since the beginning of the collection of the data, despite the fact that this is not a probability sampling. Finally, the conclusion is that the making of surveys faces new challenges and advantages. We have advances in computing, we have reduced budgets, we have methodological advances, and an increase on non-response rates. And that the response adaptive surveys are a set of methods that might allow us to do useful surveys in these new times. Thanks for your attention.
Are there any questions for Martin? So, I don't know if someone could help us with a microphone.
My question is related with the first survey. The survey, you use a very complex sampling design. Do you have the theoretical estimator of the variance? And the other question, how do you take in account the non-response? Because you show in a slide that the non-response is not completed at random. So in that case, well, I assume that you have to take into account the non-response in the variance estimation.
Yes. The procedure for adjusting non-response is more complex than I show, because in the real survey we took in account the area, that is a set of states, and the age, and also the response rate by PCU. And just the sampling design is more complex, but the bias, the thing that we do to check the bias is to verify we compute several estimators and verify that our estimators are close to the targets, and that helps to get confidence on the estimators. And let me say one example. For example, we have a long story on the estimator of the prevalence of diabetes, a long story on hypertension, in many medical parameters. Then, if one survey do well on that parameters, give us confidence that the bias is not significant. That is the sort of verification that we do.
Thank you. I have two questions. The first one is, You said that you control for the first survey for no children and no women. So when you have on the first stage that the household doesn't have children nor women, you don't go. But on the third stage, you showed that the non-response rate decreased.
No. We went to all the strata. The strata was household with children, household without children and with woman, and household without children and without woman, and no information. And then we are allocated a sample size for each strata.
Okay.
Uh-huh.
Okay.
And we went to the 4 strata.
So, yeah, I got confused because I don't know why the percentage of households with no women and no children in the third stage still remains. Well, it decreases, but it is still,
Yes.
it's still there.
Yeah.
So,
Yes, we went to the 4 strata because the first visit was a very quick
verify.
visit.
Yeah. Okay, great. And the second question, sorry, is you showed us a graphic for morbidity and non-response rates for years of schooling, and you have 2 graphics, one for only elementary school, and the second one is just for more ages of school. So the question is, have you ever tried with having secondary school? I mean, Mexican average of school is 9 years, about third grade. And the question is, why didn't you do that split?
Yeah. The trend is the same. I did it because in this plot, we split the population on 50%, basically.
We have time for one more question. I think that Guillermina here have here. Okay. Last question.
Thank you very much, Martin. I was very impressed by the graph you show about the elections, the one with the prep. Partly because I have seen, I thought it was a quick counting, but it is the prep.
It's the prep.
You get estimators since the very beginning till the end.
Yeah.
So I know you have experience also in quick countings and in all those pre-election and so you think that one may rely in this, no. You think that these estimators can sort of substitute the quick countings? Because they were very precise.
No, because they are not probabilistic. But they are very precise under the assumption of the model. Because here, my point is, if we verify the model or I have reasons to suppose the model, I would say that I will have confidence on these estimators, because as the simulation shows, the ratio estimators gives good estimators despite that the probabilities were wrong.
Thank you.
Well, yes, we'll have some questions about the prep, but well, I think that we don't have more time. But it is interesting because the estimation that you show there, I remember that the prep showed first at 10 p.m. that Felipe Calderón was below López Obrador. And when we went to sleep, like around 4 in the morning, lines crossed. So when we awoke, Felipe Calderón was winning, and López Obrador was losing. So it was a great shock for us. So in your estimates, it seems that this estimation of the weights kind of solves that. So it's very interesting. But I think that we have no questions. I think that we will ask for you later. Well, thank you. Let's thank Martin again, please.